Application of context-free grammar in natural language processing. Introduction. In this presentation, we will explore the power of context-free grammar in revolutionizing natural language processing. We will delve into the principle, application, and impact of this fundamental concept. Grammar. What is grammar? Grammar is defined as the rules for forming well-structured sentence while describing the syntactic structure of well-formed programs. Grammar play an essential role. In simple words, grammar denotes syntactical rules that are used for conversion in natural languages. The theory of formal language apply not only to NLP but also in the fields of computer science, mainly in programming language and data structure. For example, in C programming language, the precise grammar rule states how functions are made with the help of lists and sentences. Mathematical representation of grammar. A grammar G can be formally written as a four tuples N, T, S, P, where N or Vn is a set of variables or non-terminal symbols. T or sigma is a set of terminal symbols. S is a special variable called start symbol. S belong to N. P is the production rule for terminals and non-terminals. A production rule has the form alpha belong to beta, where alpha and beta are strings on Vn union sigma, and at least one symbol of alpha belong to Vn. Contextual grammar. What is contextual grammar? Contextual grammar, which is in short represented as CFG, is a notation used for describing the language. It is a superset of regular language, which you can see from the following diagram. CFG consists of a finite set of grammar rules having the following four components: set of non-terminals, sets of terminals, sets of productions, start symbol. Terms related to CFG. Sets of non-terminals. It is represented by V. The non-terminals are syntactic variables that denotes the sets of string which help define the language generated with the help of grammar. Set subterminal. It is also known as token and is represented by string, are formed with the help of basic symbols of terminal. Sets of production. It is represented by P. The set gives an idea about how the terminals and non-terminals can be combined. Every production consists of the following component: non-terminals, arrows, terminals, the sequence of terminals. The left side of the production is called non-terminal, while the right side of the production is called terminal. Start symbol. The production begins from the start symbol. It is represented by S. Non-terminal symbols are always designated as start symbol. Parse tree. A parse tree or parsing tree or derivation tree or concrete syntax tree is an ordered root tree that represents the syntactic structure of string according to some context-free grammar. The term parse tree itself is used primarily in computational linguistic in theoretical syntax. The term syntax tree is more common. Concrete syntax tree reflect the syntax of inputs language, making them distinct from the abstract syntax tree used in computer programs. Natural language processing (NLP). NLP stands for Natural Language Processing, a part of computer science, human language, and artificial intelligence. This technology is used by computer to understand, analyze, manipulate, and interpret human language. Natural language processing is a subfield of linguistic, computer science, and artificial intelligence concerned with the interaction between computer and human language. In particular, how to program computer to process and analyze large amount of natural language data. NLP algorithms are widely used everywhere in area like Gmail spam, any search, games, and many more. Components of NLP. NLP is divided into two components: natural language understanding, natural language generation. Natural language understanding. Natural language understanding NLU helps the machine to understand and analyze human language by extracting the text from large data such as keywords, emotion, relation, semantics, etc. Natural language generation. It is a process of extracting meaningful insight as phrases and statements in the form of natural language. It consists of text planning and sentence planning. Explain the role of CFGs in parsing natural language sentence. Context-free grammar play a crucial role in parsing natural language sentences. Syntax analyzing. CFGs are used to describe the syntax of natural language. They define the role for forming well-structured sentence. For example, a simple CFGs can be used to generate sentence in English. Parsing. CFGs are used in parsing, a crucial step in natural language processing. Parsing is the process of analyzing a string of symbols either in natural language or in computer language. According to the role of a formal grammar, the parser use CFGs to break down sentence into their constituent parts and identify their syntactic role. Semantic interpretation. After parsing a sentence, CFGs can help in understanding the meaning of sentence in a language. They help in mapping syntactic structure to semantic representation. Machine translation. CFGs are also used in machine translation. They help in translating sentence from one language to another by understanding the grammatical structures of sentence. Application of CFGs and NLP. Syntactic categorization in NLP. NP, noun phrase. VP, verb phrase. S, sentence, determiner. N, noun. TV, transitive verbs. IV, intransitive verb. Pre, preposition. PP, preposition phrase. Adjective. From contextual grammar, we can say S belong to NPYP, which means a sentence is defined as a noun phrase following by a verb phrase. A sentence in a language defined in a CFC is a series of words that can be derived by systematically applying the rule, beginning with a rule that has S on its left hand side. For example, a parse of a sentence, the giraffe dream is S is defined by NPVP, noun phrase, verb phrase. Noun phrase is split into determiner and noun and VP. The is the determiner, giraffe is a noun. Verb phrase is here is intrinsic verb, which is dream. That's how we get the giraffe dream. A convenient way to describe a parse is to show its parse tree, which is simply a graphical display of the parse. Advantage of applying CFGs in NLP. CFG provides a formal framework for describing the syntax of a language. CFGs consist of a set of rules that define how words and phrases can be combined to form sentences, making them a useful tool for analyzing the structures of natural language. CFG is capable of generating a infinite number of sentences that are grammatically correct. This allows NLP system to recognize and generate a wide variety of sentence structure, which is essential for applications such as text phrasing, machine translation, and language modeling. CFG can be easily phases using algorithms such as CYK algorithm. This make it possible to analyze the grammatical structure of a sentence and extract information such as subject-verb object relationship, which is useful for tasks such as sentiment analyzing and name entity recognition. CFG can be used in combination with other techniques such as probabilistic model to improve the accuracy of NLP system. For example, CFGs can be used to generate candidate parses of a sentence, which can then be scored based on how well they fit with the context of the sentence. Enhancement and abstraction. To address the limitation, researchers had developed probabilistic contextual grammar and dependency grammar to capture deeper semantic relationships. This enhancement has have significantly improved NLP capabilities. Real world impact. The advantage in contextual grammar has revolutionized NLP, leading to breakthrough in sentiment analysis, text summarization, and information extraction. Its impact is felt across various industries. Future perspective. As NLP continues to evolve, the role of contextual grammar remains pivotal. The integration of deep learning and contextual grammar shows promise in addressing complex linguistic structures and semantic understanding. Case study. A machine translation. Contextual grammar play a critical role in development of statistical machine translation system, enabling the accurate analyzing and generation of translated sentence across language. Ethical consideration. The use of contextual grammar in NLP raises ethical questions related to bias, privacy, and misinformation. It is essential to address this concern to enhance responsibility and inclusive NLP practices. Adoption and integration. Organizations are increasing integrating context-free grammar-based NLP solution into this workflow. The adoption of this technology is reshaping communication, customer support, and decision-making processes. Advancing human machine interaction. The advantage of it context-free grammar are deriving the evolution of conversational agents and virtual assistant, handling the naturalness and effectiveness of human-machine interaction in diverse domains. Challenges and limitations. Contextual grammar have been a fundamental tool in natural language processing. However, they do have certain limitations when it comes to their application in NLP. Inability to capture dependency, lack of semantic understanding, overgeneration, enable of to handle ambiguity, limited context, sensitivity, lack of world knowledge. Conclusion. In conclusion, the power of contextual grammar in revolutionizing NLP in undeniable. Its fundamental role, coupled with ongoing advancement, is shaping the future of natural language processing and human machine interaction. Thank you.